Here we're going to talk about how are matrices related to systems of equations. And remember, we talked about our systems of equations when we did our linear programming problems. And so we're going to relate that back to how a matrix is used here. And so in a system, remember, you have multiple equations, multiple linear equations. So here we have two different equations that we want to solve at the same time, right? Well, from a system, we can create three new matrices. And the first one is what we call the coefficient matrix. And in the coefficient matrix, a coefficient is just the number in front of the variables. So when we create the coefficient matrix, here's what we're going to get. For this coefficient matrix, we get the first coefficient is the number 3. The next coefficient is the number -4. On the second row, you get a number of 2, and then you get a number of 5. So it's just the number in front of the variables. So here's what we call the coefficient matrix. And it's just me taking the coefficients in front of the actual numbers. Now, a constant matrix is everything that's on the other side of the equal sign. It's everything on the other side of the equal sign. So in this case, our constants are going to be these values back here. So it's just 7 and -2. And notice that the constant matrix itself is just a column matrix. It's a column, right? And then the last thing we have is what's called our augmented matrix. Well, the word augment means to help or to enhance. So when we do this, we're going to actually bring these two things together. And so when we get this, we just attach. We're attaching the constant and coefficient matrix together. So you're going to get this now. 3, -4, 2, and 5. That's the coefficient matrix. And we're going to augment or attach this 7 and -2. This bar right here, this imaginary line, is just me saying that I'm augmenting it, which tells me that this is the constant side and this is the coefficient side. So here are examples. Let's write the coefficient and constant. Let's write the coefficient, constant, augmented matrix for each of these system equations below. So I have, in this particular case, the coefficient matrix first. I'm going to create. I have the numbers on the first row. I have 1, -2, and +2. And I have second row 2, -3, -2. And in the third row I have 1, -1, and 1. Here's the coefficient matrix. The constant matrix is -1, 3, -1. And then if I augment those, if I augment these matrices, here's what I get now. 1, -2, 2, 2, -3, -2, 1, -1, 1. So that's the coefficient matrix. And I'm going to augment the constant with it. There goes my 3 matrices. The next one I have, first row, I have 1, 1, 1. Second row, 2, 2, -1. Third row, I have 1, -2. And notice that I don't have a z variable down here. So we don't have a z variable. That means we have a 0. So here is your coefficient matrix, constant matrix, 4, 2, 7. And then the augment of these matrices, 1, 1, 1, 2, 2, -1, 1, -2, 0. And I'm going to augment the constant matrix with it, 4, 2, 7. So that's how we create the actual coefficient, constant, and augmented matrices. Those are the 3 matrices we can get from a system. So now when we talk about actually solving these matrices, the first thing we're going to talk about, though, is generally what happens is we write our matrices without the variables x, y, or z. We always use the variable x, and we call it the generalized system. And in particular, each row in a generalized system represents a new equation, and each column represents a new variable. So if I want to write an actual equation from a matrix, and realize that these are augmented matrices, even though the lines aren't there, these are augmented matrices that have a constant matrix and a coefficient matrix attached to each other. If I want to write this, I need to realize that for each one of these, I'm going to represent these now using the variable x in subscript. So what that really means is that here is the x1 variable, here is the x2 variable. In this particular equation, here is x1, here is x2, and here is x3. So each column represents a different variable, and each row represents a different equation. So if I want to write the first set of equations in part A, this is just the coefficient is 3x1 plus 4x2. That equals 1, the constant. That's the first row. The second row would be x1 minus 2x2 is equal to 7. So notice this. These make up the columns. If you go down and they're the columns. These rows make up each equation. Next one, I have x1, and there's no x2, so the last one is plus x3 equals negative 1 for the first row. Next row is 2x1 minus 2x2 plus x3 equals negative 2. And then the last row is negative 3x1 plus 2x2 minus 3x3 equals 5. And notice again, all we're doing is we're calling each variable, instead of using the variables x, y, and z, we're using the same letter x, but we're subscripting it with 1, 2, and 3, or however many variables we may have here.